Hi, so let's talk about merge two binary tree. So you are given two binary tree, root 1 and root 2, and the idea is you have to add a value together, and then you have to return a new tree. It doesn't matter you return a new tree or not. You can actually put the second tree into the first tree, so you can save a lot of space. And in this video, I'm going to talk about BFS. So BFS is preferred search, and I'm going to use a queue to store every single node, and then I will add the value together to the first tree. And um, this is going to be simple, and just follow along. So the base case is this: if root 1 is equal to null, then I will return root 2, and if root 2 equal to null, I will return root 1. And you can actually um, make it shorter. So if root 1 is equal to null or root 2 is equal to null, I will actually return to check if root 1 is equal to null. I will return root 2 else root 1. This is the shortest version for the two if statement. Then I should create a linked list. So linked list should store the tree node. And say q equal to new linked list. So what I will do, I will add the root 1 and root 2 to the queue first. Q.add root 1, Q.add root 2. So in order to do the buffer search, you definitely need to know if the queue is empty or not, right? Because you keep adding the node into the linked list. So if queue is empty, queue is not empty. By the way, queue is not empty. So I will pull the value I just stored into the queue. So that would be 1 and 2, right? So I would definitely say tree null. I'm gonna say left equal to queue dot remove, and then right would be queue dot remove as well. So what I meant left and right is this is the first, the left, which is how you actually add into the queue. You add root 1 into the queue first, root 2 the second. So left will be root 1, right will be root 2. So in this case, I'm going to add the second tree to the first tree. So l.val plus equal r.val, and I need to check the child, right? Left child and right child. But in this case, I'm going to check the left child. So if the left child, if they are XX, right, I can still keep going down, right? So I will say if left is not null and r.left is not null, and Q will add the left left and then r.left. Okay, and this is how it is. And what happens if you only have one child? Imagine you don't have this child and you have this child, right? Then you just need to assign this child to the left child. And then if you only have the left and doesn't have right, then we don't care about it. We can just remain the same because you are still going to add this into a queue later um, if you are going to traverse to the bottom. So I will say else if l.left is equal to null, I will just assign l.left equal to r.left, and everything will be the same on the right side. So if r.left, sorry, r.right, come on, sorry, l.right, yeah, this and r.right is not equal to null, I will say q.add Alt right, Q dot add, L dot right. So I just make a mistake. Do you know? I switch the order. So I should use the L dot left, L dot right first, and R dot right. It has to be a pattern because when you remove, right, you are remove the first in the queue. So the first one is always the left tree, second one is always the right tree. Then you are definitely going to check L dot right. And at the end, you just need to return root 1. Why? Because you are updating root 1 I mean inside this while loop. So we can actually check. Alright, make a typo. Link this. Yes. And here we go. So this question is not hard. You just have to know where you actually need to assign. And for the time and space complexity, I would say time is all of n. Why? Because you need to traverse every single one, a tree, no, right? And space, it should be all of n divided by 2, but we will get rid of constant, so that will be all of n. So both are all of n, and that will be the solution for BFS. And that will be the video. And if you like the video, press like, subscribe if you want it, and I will see you next time. Bye.